Recording. We remembered once this week. Okie dokie. How is everybody doing today? So, as a reminder, you all have um, homework due on Friday. Good morning. So yeah, homework's due on Friday. The last question for your team setup, if you haven't figured that out by now, I noticed there's, I think, 4 people looking for a team in the Discord chat. That might be a good way to self-organize right there. The four who missed the four who either missed the meeting or who didn't get into a team at that point might be a good group to form. You will all get chat channels and voice channels in my Discord server. You'll have roles for that, so you only see your own channels. And, if you want to self-organize elsewhere, that's fine too. Got my 2-year-old's tie on here because my 6-year-old told me it was required for today. We're talking about ethics, so got to be a little bit professional here, I suppose, right? Yeah, can't do ties, I'm sorry. And let's see, what else is going on? Yeah, other thing. I knew there was something else I wanted to talk about, and I was trying to figure out what that was. Exit, Google, be useful today. So I posted a couple of other things in not Banner, Blackboard. And I just wanted to make sure that you were aware of that. So I moved the deadlines to the homepage just to hopefully make it a little bit easier before his underclass sessions. So you have a in-class assignment today that we'll be doing, and then you have a homework which I'll be posting pretty soon. So I'll post it probably Friday after your first homework's due, so you're not overloaded. But that's going to be due February 3rd. Actually, I'll probably post it today just so that you can have it. It's just an introduction to Git, and it's a little web interface to go through to understand what all the different commands are. Nothing too horrible, honestly. But you will have that, and may push the deadline back since your current deadline's Friday. I don't really want to do overlapping assignments. That would be just cruel. Okay, maybe we'll push that back. Chrome, come back. Okay. So we have that. And then Friday, what we will do is we will actually talk a little bit about Git as well, since you'll be using it for your term projects. Make sure that you're all aware of that. And I know not everybody knows Git at this point. That's not an expectation coming in, but you will pick it up in here. Unfortunately, or fortunately, some kind of revision control system is absolutely required for a good software project. So, enough of the overview. Today we're going to talk about ethics in kind of a more or less a high level. Mainly, we're going to look at a couple of other case studies, and I'm going to have you all discuss them in Discord rooms. So at some point during the lecture, I'm going to have you all pop over to Discord and try to answer the questions that I've posted in here. This will be one way that we do in-class discussions, when we're on Twitch, not on Zoom. So I'll get to that. So what are we going to go over? What are ethics? Why are ethics? What are the differences between normal everyday ethics and what you might have to deal with in the workplace, your professional ethics, and then the software engineering code of ethics. And again, there's a little bit of overlap here with 290, but really the key takeaway here is that it's very important to pick this stuff up and be aware of it. How are ethics? Do I have that in here? I don't have how, sorry. I have to add that in next time. How are ethics? I like that. All right, so what are ethics? And these are all, things that which you probably already are aware of, honestly. But what we care about here is dealing with issues that you may experience and the good sides, the bad sides, and what you do if you come into contact with something, right? Um, Basically, it's going to be like your set of moral individual principles or professional principles. And kind of the key takeaway here is there's not going to be, black and white. If you discover this, it's a horrible thing. More or less, you're probably going to discover lots of gray areas. In the business world, or at least in industry, your ethics are going to be kind of, you're going to see little things and built up over time. It's going to seem like a horrible catastrophe. But when you start at the very beginning, sometimes these things that we just say, it's fine about, they turn out to be really explosive bad things way later on. So having a good set of ethical principles is kind of a good thing to get going in too. And really what you can consider it is to just really do the right thing if you can. Um, and doing the right thing is not always obvious, right? Like I said, it's not black and white. There tends to be a lot of gray areas. Like if you have, let's talk about this in terms of software engineering, because this is the class we're in, right? But let's say you come across a lazy bit of code writing, for instance, right? So if you are in the automotive industry or some kind of a embedded systems industry, maybe you're working at GE in aerospace engineering or something, and you're doing a code review for a new developer. New developer doesn't have a lot of experience with C because they've done everything in Java forever, and they don't really do a great job initializing their variables, and you let it slide in the code review because they're obviously flustered. It's their first meeting. So, we'll go back and fix that later. That's we're not going to mark you mark this release as a failure or something like that. And then you forget about it. And then that problem kind of balloons up, and then you have a variable, which if you're not aware in C, if you don't initialize them, it could be anything. And then that causes a plane to crash because we made a little tiny decision early on. Almost kind of get a butterfly effect type of thing going on here. So the point is that it's not always going to be like this world-changing, earth-shattering, oh my God, do we do this or we do this? It's an obvious decision. Sometimes it's just a little one. And the other thing too is maybe it is a big one. It's kind of situation dependent, right? But one thing that you can do is if you are in a situation where you realize, there could be an ethical problem here, maybe you restate the issue. So rather than looking at the problem and say, do we do this? You might want to ask, is it right to do this? And then if you start thinking about it, maybe from a ethical perspective, it can kind of help inform your decision. And again, this is some of that gray area, touchy-feely type of things for programmers or for project managers. These are situations you may find yourself in someday. Right now, it's kind of laughable that, we'd ever see this, right? But it can happen. What about if you're a phone app developer and one of your, one of your project team members wants to start collecting your personal information from the user, right? So we are creating an app. Okay, we need to authorize the app on the phone. We need access to your calendar, your contacts, your photos, your local files, your, I said contacts, other apps on your system. And you have this big laundry list of data that you are now privy to. But your phone app is a calculator. Ethically, that's kind of not a good thing, right? You shouldn't be looking at all the or have access to all this other data. It's maybe somewhere down the line, you bring in somebody else who sees that and says, oh, score, I can look at everybody's personal information now. So see a lot of ethical things on, in mobile apps with permissions and things like that. Did you all see the recent news story about ADT? That was kind of a fun one. One of the ADT employees, basically, that's the security company, admitted to hacking people's private camera streams and watching people in their homes for, I think it was 4 years. So not always a good thing to have access to things you shouldn't. All right, so I said how are ethics, right? So we had what, now we have why. Basically, with good ethical choices, this leads to good consequences. And bad ethical choices generally leads to bad consequences. And then probably it's going to cost a lot to clean up for you or your company later on. Interestingly, in terms of where you're going to fit into this puzzle, you're going to be in kind of the scientist engineer domain, project manager domain, right? So the engineering side of things. You are iterating technology, you're making important decisions for your business, the technologies you're making, and that's going to inform public trust in your company. And if the public doesn't trust you because you're making poor ethical decisions, products are not going to get bought, your company's going to have issues, and you don't want that to point to you. But kind of the key takeaway is, let's try to have a nice, happy, fluffy cloud, make good decisions, um, basically do your best in all situations is what you can really hope for. And the reason we talk about this in terms of software engineering, ethics, touchy-feely stuff, make good decisions, isn't that like below us as a college level, you might think. Again, these issues will crop up, and you have to understand how to deal with them as you go. Now, one thing to kind of consider when it comes to ethics, you don't have to be the expert in this domain as well. If you're working for a company or you're in education or you're in academia or whatever you are, you can ask other people for their opinion too, right? Sometimes you have unofficial, well, I guess official but anonymous ombudsman type people where you can talk to them and ask for their opinion relating to your company or whatnot, and they'll give you an honest answer. And it's all anonymous, so you don't have to feel bad about asking the question. Just don't feel like you're alone if you come into a situation like this. Generally, you should be able to talk with people about problems like this. But that's the touchy-feely stuff. Let's kind of step away and actually talk about it in terms of your professional responsibility. Because again, you're going to be in the working world in some fashion. Now, if you're in industry of some kind of a field, and let's take software engineering, for example, you are an expert in that field, right? You graduate college, you go on to work for a company, you're making a product, you're working on a team. You are a professional expert, right? You have knowledge that other people do not have. That makes you have special responsibilities with respect to this product, right? If you make a decision early on, for this product, that's going to impact a large number of people who are using this product, right? Let's say you work for Tesla. You make the decision to not worry about firmware updates for your screens. Just assume you're never going to hit that write cycle limit. Well, now every single Tesla owner needs to go get their screen replaced. I have no idea what led to this decision, but based on probably something that was thought of, I'm sure somebody brought it up at the very beginning of a product cycle, it has now ballooned into a massive issue. So whether it's a bad decision, whether it's dishonesty, whether it's carelessness, whether it's incompetence, whether it's just sheer happenstance, it's very possible to cause harm. And this large, bold font is intended to hopefully try to get through to you if you've kind of tuned me out already. But what does harm mean? Harm can mean injury, it can mean cost, it could be damage to products or to infrastructure of some kind. Again, you are becoming an engineer of some type, right? The things that you build will be used by people. So make sure that you actually treat it with the respect it deserves. So enough of scare tactics. We'll talk about a little bit of an extra case study later on. But one thing you should be aware of is that there is a code of ethics, a code of professional practices. This was jointly developed by IEEE. Breach of privacy, there you go. Absolutely absolutely an ethical thing to deal with. But this code, jointly developed by IEEE and ACM, so these are two of the big groups of engineers and academics. So IEEE has computer science branches, but it's electrical engineering and CS. Here we have the ACM, Association of Computing Machinery. Basically, you probably may or may not have heard of these groups, but more or less engineers will tend to join them, get access to all the research papers, have meetings, groups just to talk, things like that. But they came up with a list of principles for ethics. And they have a code specific to your responsibilities to the public, to products, to management, to your profession, to yourself, so on and so forth. We're not going to go into this in detail. Again, it's probably more of a 290 thing for that. But the takeaway is that you should try to be as ethical as possible with respect to your professional responsibility. You could be a terrible person in private if you want, but when you are acting in the capacity of a public figure, right? You are an engineer. Whether you're hiding in a cubicle, you're still developing a product. You should be as ethical as possible with respect to your professional principles. Other interesting thing too here. So again, this is a very large amount of basically specifications for each of these. It's not a simple algorithm. You don't just go through tick, did I satisfy the public? Check, did I, satisfy my client or employer? Check. Basically, it's a list of, basically it's a code of ethics. It's kind of hard to describe. So we'll kind of go through these a little bit here, and then we'll get into the case study. So your code of ethics for the public. You shall act consistently with the public interest. That's kind of debatable, right? There's a lot of gray areas with this. What is the public interest? Well, consider it that you're building something. It should not intentionally go out and hurt somebody, right? What about in terms of your client and employer? You shall act in a manner that is in the best interest of their client and employer consistent with public interest. So basically, and again, I'm not going to go through each of these, but if you are working in some capacity for a client or for your employer, you're not going to intentionally go out and subvert what they're expecting you to do. You're not going to try to damage them from within or give your client a crappy product intentionally. I mean, I know there are companies that do that, but you shouldn't be doing that. And that also goes backwards too, right? So make sure you're okay with your employer while still being okay with the public, unless you are the Zuckerberg. Haha. We could talk about Facebook and Parler and all of these horrible ethical things going on right now. I've intentionally stopped using Facebook personally. I have a page there still, but just for work purposes. The things that coming out for these companies are just awful. Yeah, definitely a lot of ethical case studies in media right now. And if they're coming out as ethical case studies, it's probably a bad thing, right? Funny thing is too, like yesterday I finally came across that it's the Sassy Justice YouTube video where it's got the deep fakes and Zuckerberg's in it, and it's made by the South Park guys. It was hilarious and scary. Basically, two people who shouldn't have access to deep fake technology. Yeah, I saw that. That's a shock to nobody, I think. But basically, we have all of these lists of categories, right? For all of these categories for ethics. They all build on each other, right? So we have public, client, product, judgment. So use your integrity, be independent, um, your management, your professional interests, your colleagues, yourself. Basically, be ethical in all of these capacities without sacrificing ethical concerns for another. And depending on if you encounter something earth-shattering, right? You are the whistleblower at some company who has uncovered something. Then you're putting the public's interests over your own, right? Some of the text is, oh, sorry about that. You are absolutely right. Let me fix that. Up, up, up. We're gonna get small for a moment. Yeah, sorry, yesterday I was teaching in another room and I have a smaller external monitor in there. Yeah, sorry about that. Yes. Distract them with the dancing blob. All right. But kind of the key takeaway is that you're going to have to make these ethical decisions, and it's not always going to be obvious that you're making them. Having a set of guiding principles of how to behave, at least to try and help you along the way is very helpful. And again, if you have somebody you can trust, if you come across something, talk to them by all means. Don't make this decision all by yourself unless there's nowhere else you can go. But yeah, lots of examples in the media right now about ethics. So let's talk about some of the case studies, right? So you have to do this for homework. We're not going to talk about Therac too much here, but if you remember, this is the chemo machine. And again, if you haven't read the articles yet, I think one or two people have submitted the homework already, so good job. But it's just reading articles and write like a paragraph on each of them, basically. But Therac was the chemo machine. We had some problems here. In terms of ethics, is how we're going to talk about this now. We have some specific things going on here. So institutional culture, right? If you remember, there was no source code reviews independently. It was all one person. We never really assessed how the software might fail. We didn't do a great job. Well, they didn't do a great job of testing it, right? The UI tended to be actually quite bad as well. So if you see malfunction XX, you don't know what that means, right? What is X? XX is going to be a number here. Well, that's going to be a lookup error code that the medical staff is going to have no idea what that means. Plus, you're allowed to override that. So if you see this error pop up and you can just turn it off, does that mean an error happens? If you are a non-engineer, right? You're probably just going to pretend it's like the engine light on your car. You just ignore it until it goes away and your car's fine, right? Which don't do that. Fix your car. But we have problems all around here. Complaints from staff and from people who were given the radiation. They didn't believe the complaints. There wasn't any integration testing where you have hardware and you have software. You test them separately and they're great. Then you bring them together. You're supposed to test it again to make sure that it still works. That didn't happen with Therac. So we have basically some company-specific problems that happened here, right? So the institutional culture. There is also the engineering side of things, the actual technical problems, right? So we didn't take into account any unexpected inputs. The hardware we talked about, we got rid of that. We reused old code, which, hey, code reuse is absolutely wonderful, right? That's what we want to do so we don't have to duplicate efforts. But we didn't go back and check it to make sure it was still working with this new hardware. Race conditions, the hardware backups went away for verification. So we missed out on the safety measures. There wasn't also any like sensor backups to make sure that this reading that we're getting is correct. Usually you need to have something to verify your readings. And there's a fault flag that could be overrun. So it's just an incrementing error counter and it can reset to 0. Kind of like your nice little Donkey Kong. Go to 255 and is it 255 or is it higher? But resets to 0 when you're done. So we're not going to, basically, we don't have to do this right now. We'll do this for the Challenger when we talk about that next. But I just want you to consider all of these things that happened, right? So we have all these problems, right? And we've talked about them at length and you're going to read about them. These are all small decisions that boiled up along the way. No independent review of source code. So pretend we are in the late 80s, mid 80s, and you're the programmer working on this machine. I deliver it to my project managers, and not one person thinks to have anybody check our code. Or somebody brings it up and everybody else says, nah, it's fine. One 5-minute decision leads to this, right? It is a part of it. Poor UI design. Again, late 80s, we don't care about user interfaces at this point too much, right? We don't have the UI research that we do now of how people use machines. But we probably also didn't have any testing with the people actually using the machine. Nobody thought to bring in a nurse or a doctor or a lab technician or whatever person's using the machine and say, hey, does this make sense to you? Or, hey, the system failed. This is the error that pops up. What do you do if you see this? I'm sure that didn't happen, right? Because nobody understands what this means. Did not take into account unexpected inputs. If you are a web designer now, right, you make websites that talk to databases. one of the first things that we drill into your head, so at least I hope we do, sanitize your inputs, right? Don't accept data that you do not understand. In this case, we're looking for a series of key presses, and we don't care about all the other ones. And it turns out that when you do all of the other ones, it's going to... Hi, not right now, honey, okay? Yes, okay. Sorry. Um, we just ignore them. And then what happens in programming if we ignore things? Anything could happen, right? And in this case, it did. It locked up the system. And all of these other issues, you can look at these separately, and you can probably imagine all the decisions that led to them. Why do we have to worry about all these other buttons on the keyboard if we're not using them? We're saving money by getting rid of the extra hardware we have to manufacture. Great. We're saving, thousands to hundreds of thousands of dollars on these expensive machines. If we take this part out, it's going to save us on the build cost. But now we don't have a safety backup. All right, so there's all these issues, and you can hopefully see what they're going to lead to. So let me show you here momentarily what we're going to do here. So we're going to talk about the Challenger explosion from a little bit back. In Discord, I've created some chat rooms here. Let me bring this up onto the screen. So under the CIS350 category, I've got groups 1 through group 4. So what I'm going to have you do is once we're ready, I'm going to have you all kind of filter into these rooms and talk about what's going on here. And while you're doing that, I'm going to unhide the in-class assignment for today. Basically, just like last time with the assignment, nominate somebody to record your answers with everybody's name and submit it to Blackboard. So that'll be our in-class discussion for today. And I've got some text to help you out there. So, anybody remember the Challenger disaster from the late 80s? Yes. Yeah, I do too. Although I would not have been very old when this occurred. Yeah, rocket boom. Yeah, it was the teacher was on there. But at least when I was growing up, they never told us why this happened. I think the teacher was from Michigan, yeah. I'm pretty sure. Anyway, so let's set the context here. So we have this, spaceship that's going up. You have the teacher that was the big, feel-good news story that a teacher is going to be on this thing. Shortly after liftoff, so pretty soon, you start seeing issues with one of the boosters, then you start seeing flames, and then it explodes, right? 7 people died. So this was a big issue, right? People died, our rocket exploded. Not good. I never okay, thank you, New Hampshire. So what happened though is this was actually an engineering problem with project management decisions that led to it. This wasn't a oh shit random encounter. There was a decision that was made that led to this problem. And I didn't know this until, I started looking into this mainly for class. But what occurred here was that there were O-rings, and these are just a little, little rubber or some kind of material which, seal joints. So they're usually like little squishy things that you bind metal together with, or that you seal metal together with. So they were actually inappropriate for the rocket. And what happened was that based on the temperature at the time of launch, it was 36 degrees, meaning that these O-rings were too cold. They could not handle what occurred when the rocket blasted off. Right? Normal everyday situations, yes, they're fine, but if it gets too cold, this material probably hardens and it can't handle liftoff. And the interesting thing here, and I say this interesting purely emotionless, it's absolutely awful. The engineers knew about it. They told their project management this was a problem, do not lift off today. They did it anyway. Rocket explodes. had advised against launches in ambient air temperatures below 53 degrees. So basically, we have like a 20-degree Fahrenheit differential here, where if you had waited till these things warmed up, it would have been fine. But the decision was made to launch, and they couldn't handle it. So, um, what I'd like you to do now is to talk about this a little bit with this extra information. And I've got a little bit more. No, I don't have a little bit more. I thought I did. Um, I'm going to pull up the article in the interim. But join one of these. Well, this is different now since we don't have two sections. Basically, one of these four groups. And what I'd like you to talk about, I'll get to your question in a second here. Um, so who is at fault here? Why are they at fault? And what should have been done differently? And while you are doing that, let me ask first, does everybody understand what has to happen here? So pop into Discord into one of those rooms. I will pull this up too. So here's the article if you want to peruse more. No, I don't mind unblocking you. Oh yeah, there's lots of issues here. Basically, the report went in and they did a full deep dive onto all the problems that could have happened. I mean, they watched videos of the event. They looked to see where the actual failures occurred. Basically, there was a deep dive into what happened. Yeah, so they're looking at the circumstances, the evidence, what's the mechanism of failure. Basically, they just went through and did a whole deep dive onto it. Probably coupled with the fact that people were reporting that this was a problem, probably helped with the investigation, honestly. But do I see people in rooms? Let me pop this into chat. And I'll get this off screen so you don't have to worry about being on camera. I should say this worked out pretty well last semester for doing these Discord rooms. So, hello? Hey, we got people in every room. Awesome. So yeah, let me bring this over here and I will get the in-class assignment unhidden for you. Pop that up. So you've got until tomorrow at midnight to turn this in. When I say unhid, I thought I created this, but I guess I didn't. Just one person has to turn it in too. All right, it is up and alive. Okay. And one thing I should mention too, tomorrow TBD. Sorry, this is 128. I've only given you the most basic of information for this. But if you want to read something absolutely gut-wrenching, there is an interview with one of the engineers who warned their management. And basically, it's just torn him up for his entire life since then. Yeah, so I'll pop this into the chat too if you want to feel bad today. Basically, one of the people who warned them had an NPR interview. These are some of the types of decisions that you may encounter, right? Sometimes you warn people and they don't listen. All right, happy to see some activity here. That's good. Let's see, let's give you some thinking music. A little bit too happy for the material. Oh yeah, sure. Yeah, so the plan for Friday is still going to be a Twitch lecture. Friday I'm going to introduce the GitHub environment we'll be using for your... Sorry. Um, this is super loud in my ears. Yeah, so Friday we'll be doing Twitch again. I'm going to show you the GitHub environment we'll be using for your term projects, and we'll be getting into kind of intro to software engineering types of stuff. Friday night, the homework is due as well. And yeah, what I'm gonna do... Yeah, because I don't want to just give you like 2 day, 3 days. Let's make that due Friday. 2 extra days for the first thing here. So I know some people had issues with the interface last semester, so fix that. February 5th, update this, update this. All right, upcoming deadlines updated. No, nothing important. Honestly, if there is anything vital, I will send out an announcement for that. Oh, that's a good reminder that I need to send one out to my graphics class. How are we all doing for discussion timing? Still chatting, okay. One thing that might be helpful for those of you working, I don't know if you want to share like a Google Doc with everybody's names or something like that. Seems to be an easy way, or just basically just make sure everybody gets credit who should be getting credit. I really need to start doing something with these level ups too. All right, got 8 minutes here. Actually, no, let me show you. I still see a couple people wrapping up here, grinding out the levels. Awesome. So I guess what I can do while you're all finishing up chatting. So the next homework assignment, which should be up there now, I believe. Yeah, it is available. I guess let me introduce this. Where did my Twitch stream go? There we go. All right. So I gave you till Friday for this one. If you have no idea what Git is, it's an hour-long tutorial on the basics of Git. You can put it on in the background and listen to it if you want, but this is kind of a nice overview of it. You don't necessarily have to be Git experts in this class, but you should at least be comfortable with using it. If it's not Git, we'd be using Subversion or something similar. Git's one of the more popular ones right now. But what I'll be looking for you all to do is to play around with this interface here. And this is just a little guided set of things that you have to do to learn about Git. And this is not real Git in here, but it kind of gives you an idea of what Git looks like behind the scenes. So like for instance, the first thing that you do is learn all about commits. All right, so I'm just kind of skipping through here. And I click this button to make a commit. Okay, good job. I did it. This is not real Git, right? Now you would type in git commit on the command line or in your tool to make a commit, but it's just kind of a nifty little interface for that. Okay. I would just type in git commit twice. Git commit. Git commit. Hey, I've done it. Just kind of the key takeaway with this is to get you into understanding revision or source control a little bit. And if you have no idea what I'm talking about right now, you don't know what git is, you don't know what a commit is, that's fine. You will get that. You will get that. Basically, we're just tracking versions of source code and of documents and of anything you put under revision control. I'll talk about this again a little bit on Friday morning when I show you the environment. But if you decide that you want to start playing around with the homework assignment, because you have a week and a half to get it done at this point, because I just released it early for you, this is really all you have to do is just kind of show me that you've done all of the things. Okay. Yeah, where is the, go away. Refresh. Yeah, like basically I'm looking for the first 8 to be checkmarked. So that will be next time. All right. Looks like everybody's wrapping up in the Discord chat, so that's good. Chat paused due to scroll. What does that mean? Okay, we are pretty much coming up on the end of class here. Does anybody have any leftover questions or concerns? Does everything make sense from today, what I'm looking for you all to be doing? Because if you are all good, then you can head out. One person has to submit. Just make sure everybody's name is on it. And then what I'll do is I'll just go through your list of people and add up the points. What is the airspeed of an unladen swallow? Um, African or European? Aha, I'm still cool. I actually have a t-shirt I picked up off of Loot with the little sparrow and all the physics equations surrounding it. It's awesome. Some of those Woot shirts are hilarious. I think, anyway. I think they're hilarious. I'm glad to see Monty Python's still relevant. Alrighty. Yeah, so get those in. You have until tomorrow in case you need it. But just pop, one person pop that in, and I'll go through and, give you all your 10 points for that. And yeah. So just to kind of recap. Yep, bye. Homework's due Friday night. Friday we'll talk about Git and we'll talk about software engineering, instead of just the moral and ethical quandaries. And yeah, I will see you all Friday. Sound good? Bye, everybody. Office hours start in 10 minutes if you need to chat. And those of you that are unaffiliated with groups, either self-organize or I'll assign you to something after Friday. So, all right. Have a great day. Bye, everybody. Hope you have a wonderful, snowy, and chilly Wednesday. Bye-bye. Fun on the bun.